Okay, this one is a talk about basics of air conditioning. Okay, so whenever we have air conditioning design, okay, we should know that basics like the parameters. Okay, there are different parameters: dry bulb temperature, wet bulb temperature, relative humidity, specific humidity. There are many factors. Okay, so that one we will go through one by one. Clear, right? Okay, let me show you also one slide. Okay, uh, see, this is one of the website. Okay, you can able to you also can able to see that website. So here you can talk about the different type of air properties, right? You can see the dry bulb temperature, then wet bulb temperature, relative humidity, atmospheric pressure, saturation vapor pressure, partial vapor pressure, dew point temperature, humidity ratio, enthalpy, the density, specific volume of moisture, air per mass of dry air, then specific volume of air. Okay, so this is the basic properties of the air. Whenever you go to any of the air properties, you will find this properties in the air. Clear, right? Okay, now when you talk about basics of air conditioning, if you go to this particular journal, okay, you can able to see. Okay, this is the introduction of air conditioning and human comfort. Okay, so whenever we talk about air conditioning, we talk about two air conditioning: one for comfort air conditioning purpose, which is for human purpose, and the other one is for process air conditioning, which is for, say for example, you have an electrical room, or say for example you have a computer rooms, or you have a different equipment like chemical rooms. Okay, wherever you are doing air conditioning for process application, that is called process air cooling. Say for example, server room is one of the process air cooling. Okay, and if you talk about comfort air cooling, it's for human application. So there's a two type of air conditioning basically. Okay, then you can talk about a different type of the heat transfer. Okay, you can talk about conduction, you can talk about convection, you can talk about evaporation, you can talk about radiation. So when you talk about conduction, you can say that very simple. When you talk about conduction, say for example, whenever the body parts come in contact with any other object. Okay, say for example, when you have a material, okay, when you have a outside air, when it pass through some of the material, that is called conduction. Okay, so the heat will be transferred by means of conduction. So that means this is the material, the heat will be transferred through some of the material, so that is called conduction. Okay, and when you talk about convection, okay, you can see one of the word. A warmer air is lighter than cold air, it rises upward, is being replaced by the cold air. Say for example, as an example, okay, you have a vessel, okay, in that you are going to hot the water, okay, boil the water. Okay, what is happening? The hot air will go on the top side and boiled air will go on the bottom side, so the heat will be transferred within the property, so that is called convection. Clear? Within that particular liquid. Okay, so that is the convection. And radiation, say for example you have a vessel, okay, you are going to heat some of the water in that area, so that heat will be that particular heat radiation will be transferred to the nearest place, so that is called the radiation. Okay, the evaporation will be whenever you heat the water, that will be evaporated, so that is the evaporation. Clear, right? So this is the basic heat transfer. Okay, when you talk about the heat transfer, the heat will be transferred through different method. Okay, one is the conduction, one is the convection, and evaporation and radiation. Okay, so this is the basic things to understand. Then you can talk about factors affecting human comfort. What are the factors affecting human comfort? That will be temperature. Okay, if the temperature should be normal, okay, should not be hot, should not be cold, or should not be too hot. Okay, so it should be properly uh, proper temperature should be maintained, and also the relative humidity. Then the air motion, the velocity of the air is very important. Should not be very low, you will not get proper cooling, and should not be very high, you will get overcooled. Okay, so this is the factors affecting human comfort. Okay, then when you talk about the basics of air conditioning, these are the properties of the air. Okay, so you can see that when you talk about any of the air, you have a 76% nitrogen, then 23% oxygen, then 1% will be the other gases. So this is the properties of the air we are going to study, and you can see that the comfort temperature between 23 to 25 degrees Celsius, and the relative humidity will be 40 to 60%. So this is the basic design criteria. Okay, so most of the people, okay, they are comfort with this temperature range, and with this human comfort, this humidity ratio. So that is the way they calculate the comfort requirement. Okay, so they when they do the testing, okay, they will do the testing for, say for example, 100 people. Okay, so they have a different temperatures. Okay, so most of the people, around 80% of people or 85% of people, will be more comfort with this temperature and more comfort with this humidity. So that is the way they have defined this particular value. Okay, if you go to the ASHRAE thermal comfort, you will find that procedure. Okay, so remember just now we have seen that different properties of the air, right? You have a dry bulb temperature, you have wet bulb temperature, okay, then you have a dew point temperature. So when you talk about dry bulb temperature, it is a dry air. Okay, when you measure from outside with using thermometer, you will get the value. So that is the dry bulb temperature. Okay, when you talk about wet bulb temperature, by using the wet cloth, wick. Okay, so you can see the dry bulb temperature and you can using the wet bulb temperature with the wet cloth. Okay, so you will see that how much time it takes to evaporate that wet cloth. Okay, so till the time evaporation, the temperature will be dropped, right? So say for example, at one point of time, the evaporation will stop because it will be whatever the wet cloth will be evaporated, completely evaporated. Same like shirt. If you put outside for the after washing, if you put outside, after some time it will be evaporated, right? It will be dry after some time. Okay, so it will wait till what time it get dry. Okay, till the time the temperature will be reduced because it's a wet, right? So at one point of time it will stop. Okay, so that is called the wet bulb temperature. Very clear, right? And when you talk about dew point temperature, you can say that as a short, the temperature at which the moisture start condensing. Okay, so when it reach, say for example, when you talk about wet cloth, okay, you have 100% of moisture. Okay, and more than that, it cannot hold that particular water. Okay, what will happen? It will start condensing. Okay, so that is called condensation. Okay, so that means the wet cloth cannot hold more water in that particular air. Similarly, for the air, it cannot hold more than 100% of air. So if it try to hold 100% of the air, then it will start condensing. So that is the dew point temperature.
So,
Already,
just
Yeah, yeah, yes. Yeah, you can
what
tell
is
me.
what is the significance of wet bulb temperature?
See, actually speaking, okay, you cannot measure the relative humidity directly, right? Say, for example, you can measure the dry bulb temperature, okay, but you cannot
Yeah.
measure the relative humidity, okay. So what you are going to do, you are going to calculate the wet bulb temperature, and by from the dry bulb and wet bulb, you can able to calculate the relative humidity.
Okay.
Okay, for example, if you want to understand what is the moisture in the air, okay, whether it is 50% or 60%, 80%, okay, how you will identify that what is the percentage? You cannot identify. There is no, you have to calculate by using equation. Okay, if you go to psychometric
Okay.
chart, you require two values. Okay, remember just now I have seen the different properties of the air, right?
Yes.
You require any of the two values. Okay, if you know the two value, then you can able to calculate all other values. Okay, by using that
Okay.
chart. Okay, so what is the best basic method to calculate other values? You should know the dry bulb temperature and you should know the wet bulb temperature. Then you can calculate all other values. If you know what is the wet bulb temperature, what is the saturated? If you talk about the properties, there is a saturated vapor, saturated air, and also vapor partial saturated air. Okay, so by using this equation, there are different equations, maybe I can show you in coming days. Okay, even today I have shared one of the video in the group to calculate the humidity ratio. Okay, so I will be posting each and every video how to calculate each and every values by using manual method. Okay,
Fine.
you can able to calculate dry bulb temperature by using, you can calculate wet bulb temperature, you can calculate dew point temperature, all the values. Okay, but basically you require two values. Okay, so to get the two value, you have to measure dry bulb temperature and wet bulb temperature. By using this two value, you can able to calculate all other values.
Clear.
just one more doubt. Correct me
Yeah,
if I'm
yeah,
wrong.
yeah.
The dry bulb temperature will give us the sensible load,
Sensible load, yes. Wet bulb temperature will
and
give
the
you the
wet bulb gives us the
latent
latent load because there is
load.
a change in phase.
Yes.
So wet bulb, I mean the wet cloth, when once the whole water is evaporated, that temperature will be shown in the wet bulb temperature.
Yeah,
So
wet bulb
now,
temperature.
now what is the significance of dew point temperature?
No, see, dew point temperature, you are going to understand what is the percentage of moisture in the air, right? Okay, so when you talk about dew point temperature, say for example, I will tell you one of the small example. Okay, say for example, say you are going to wash the cloth. Okay, you want to dry the that particular particular wet cloth for some time, right? Say for example, during summer, it will be dry, and if you talk about
Hmm.
winter, it will take long time. Okay, because of the due because of the moisture content in the air outside. Okay, say for example, summer, you will talk about around 50% moisture. That means you have 50% space in the air to absorb the moisture. Correct?
Yeah.
And if you talk about during winter, okay, there is a more humidity inside the that means more water in the air. Okay, so it takes a long time to absorb your wet cloth. Okay, so say for example, what is dew point temperature? Assume that the outside is 100% air. Okay, 100% of moisture in the air. That means your wet cloth will not dry at any time.
Correct.
Okay, so that is the basic principle. Okay, so you will apply for different factors. So assume that remember, for example, when we talk about air conditioning machine, okay, you have FCU, for example, right? Then you have the coil. Okay, so whenever you try to cool the air, okay, what will happen? It will go to the dew point temperature. Why it has to go to dew point temperature? Because you have to cool the air at low temperature. Clear, right?
Correct.
Then only
Correct.
then only you will enter that particular close to the dew point temperature. You will enter that particular air into the space. Then it will absorb all the heat from the space. Then it will maintain as a room temperature.
Sorry. Can you this portion? I didn't get this example. Can you please
No,
repeat it?
the dew point temperature is nothing but 100% of moisture in the air. Basically, simple.
Okay.
Okay. So you will understand that what is the moisture in the air. Okay, say for example 60% of moisture or 70% of moisture or 80% of moisture. Just to understand what is the moisture in the air. Say for example, sometime if you go outside, you will feel that more humidity, right? So that means there is a more water in the air.
Correct.
All right.
Okay, just to understand, see, this is the properties of the air. Okay, so to
Okay.
understand what is the dry bulb temperature, what is the wet bulb temperature, what is the dew point temperature. Dew point temperature is nothing but it is like when it reaches wet bulb temperature and dry bulb temperature, when it reaches the same temperature, it is called dew point temperature. Simple. Okay, and why it is
Okay.
reaching at same temperature? Because it will be 100% of moisture. If you go to the psychometric chart, you will understand that when the point reaches dry bulb and the wet bulb, it will meet at 100% of relative humidity.
Okay.
Correct.
Clear, right? So when it say 100% humidity, that means it cannot hold more water in the air. Okay, so when you talk about water, okay, there is a water in the air. Okay, maybe it is very minute. If you talk about the value of moisture, okay, they will be mentioning in grams or they will be mentioning in grains. Okay, when you talk about grams, it is in metric. When you talk about SI units, that is called, you can say grains. Okay, so say for example 7620 grains is nothing but 1 pound of water. Okay, so very minute, the water will be in grams, right? Even grams also very like 1 gram, 2 grams, something like that. Okay, so that is why the moisture is calculated in grams, because it is a minute water in the air surrounding air. Okay,
This
so
is
when you talk about,
this
yeah,
is humidity also, no? Like when we say 50% humidity.
yeah, that means 50% of water in the air.
Okay.
The
Like
air is able to hold 50% of the atmospheric water, something like that.
See,
okay.
one more example. Maybe I have shown some video also in my picture. Sorry, if you see my folder, okay, there is a video psychometrics, simple to understand psychometrics. Okay, there are different videos out there. You can also able to watch in my group in my folder. See, when you talk about 50% moisture or relative humidity, that means one meter cube of space. Okay, you have 1 meter cube of air inside. Okay, so when you talk about 50%, in that particular 1 meter cube of air, you have a 50% water content, and 50% will be normal air, dry air. So this is called 50% relative humidity,
RH. Okay.
RH. Okay, so this is just to identify the water properties. Okay, your water properties will be different at different condition. Okay, if you measure inside, you will get some of the condition. If you go outside the room, you will get some of the condition. If you go to toilet, you will get different condition. Okay, so just to understand what is the properties of the air, that particular location. Clear, right?
Noted.
Okay, so you have a different properties. Okay, as I told you, if you go to this particular, if you go to this particular slide, okay, you can able to understand what is dry bulb temperature, wet bulb temperature, relative humidity, atmospheric pressure, saturated vapor pressure, partial vapor pressure, dew point temperature, humidity ratio, enthalpy, what is the energy in the air, and what is the density of the air, what is the specific volume of moisture air per mass of dry air, right? Specific volume of air. So these are all the properties you will find at different location, all these properties. If you go to toilet, if you measure dry bulb and wet bulb, you can able to calculate all other values. You can able to understand what is the density of that particular air, what is the dew point of that particular air, okay, and what is the saturation vapor pressure, and what is the atmospheric pressure. You can able to measure all the values. Okay, if you go to hall, if you measure dry bulb and wet bulb temperature, you can able to understand what is the relative humidity, how much of water in that particular air inside the bedroom or toilet or hall, you can able to measure. So this is the properties of the air. This is a basic understanding you should have before you start with any calculations. Clear, right?
So this is part of the psychometric chart.
Yeah, this is the part of the psychometric chart, and also you can also able to calculate manually, but which is not required. Okay, because we have a software, and if you calculate manually, you will not get anything, right? Because it is not necessary also. Okay, just we should know that what is the dry bulb temperature in that particular location, what is that wet bulb temperature, what is the relative humidity, what is atmospheric pressure, because this value is required. Say for example, you're performing different calculations. Okay, so you may require these values to perform the calculations. Assume that I need enthalpy, okay, to calculate what is my total energy required, or to calculate what is the capacity of the machine to calculate. So I want to calculate enthalpy means it's energy. What is the energy available in that particular year, right? So
yeah,
I may require that value. Okay, and why I require relative humidity to understand what is the percentage of moisture here in that particular location, right? And why I require dry bulb temperature to understand what is the dry bulb temperature. Okay, why I require say for example partial vapor pressure, saturation vapor pressure. By using this equation, you can able to calculate relative humidity. There are different equations. Okay, so this is the basic understanding. When you perform calculations, you will go through all these values.
Okay,
clear, right?
Yeah.
Okay. Similarly, you can able to see whatever we have seen just now: atmospheric pressure, specific volume, relative humidity, right? And you can talk about here. Okay, when you talk about dry air, you have a more dense, which is heavier, because it is a dry air. There is no. It's purely dry air, right? It's a pure dry air. Okay. When you talk about wet air, it is a less than dense and also lighter. Okay. When you talk about wet air, right? So you can see that hot air is less dense, lighter, because it's a hot air having there is no much water vapor in that particular hot air, and also you can see that cold air, which is heavier, right? Okay, you can see that enthalpy, specific humidity, specific heat, latent heat, right? So this is the total enthalpy is nothing but to calculate the total sensible load and latent heat. So when you do the summation of both value, you will get the total enthalpy. Okay, how to calculate sensible heat? There is the equations. Okay, we will talk about that equation later. And we have a latent heat. Okay, there is an equation to calculate latent heat. So when you add it together, you will get the total enthalpy, like a total heat in kilowatt, right? Okay, then you can talk about basics of air conditioning. There are different type of whatever we have seen the properties, how to plot in the psychometric chart. Okay, when you see the dry bulb temperature, you have to make a vertical line to understand what is the dry bulb temperature, right? This is just to understand if somebody don't know how to read the psychometric chart, how to measure the values by using psychometric chart. This is the basic. Okay, so if you have a vertical line, you can able to measure the dry bulb temperature. If you talk about horizontal line, you can able to measure specific humidity lines. Okay, and if you talk about this particular curve, you can able to measure relative humidity. Okay, so they are giving the basic understanding how to measure the values by using psychometric chart. Okay, if you go, there are some of the interviews when so say for example when basically design interviews. Okay, so the first question they will ask just to draw the psychometric chart. Okay, so that is one of the main questions. Okay, and you can see the saturation line. Saturation line is nothing but 100%. Okay, so you can see the dew point temperature. So when you talk about 15 degree and when it is 100%, and also you will able to see 15 degree here. Okay, so that is a saturated line. Okay, this is actually not 100%, but when you go to 100%, you can able to see dry bulb temperature and wet bulb temperature will be the same temperature. Clear, right? and you have a specific volume how to measure. So this is the wet bulb temperature, how to measure specific volume lines. Specific volume is nothing but meter cube per kilogram of dry air. Okay, how much of dry air can be accommodated in that particular 1 meter cube of air space. So that is a specific volume. Then specific heat factor, wet bulb temperature, enthalpy, dew point temperature. Okay, so this is the basic properties, right? So you can see that by using the psychrometric chart you can able to plot, you can able to locate. Okay, and if we talk about here, there is a sensible cooling and humidification, evaporative cooling, latent heat addition humidification, latent heat removed humidification. So if you talk about this particular line, okay, if you talk about one, this is a psychrometric chart. In the psychrometric chart, if you are going like the line 1, it is called heating. Okay, I think I can able to see here, represent sensible heating, right? So this is a heating. If you heat, the air property will move from this line to this line. So that is the heating. Okay, when you talk about sensible heating and humidification, so when you talk about this particular line, you have a sensible heating. Heating means the temperature also will increase and also the humidity also will increase. So that is a sensible heating and humidification. Okay, when you talk about the line chemical dehydration, is nothing but sensible heating also, and also the humidity also will reduce. So this is a different condition the air will move. Okay, if you go to different location, maybe your particular air can be in this location, or it can be in this location, or it can be in this location. So what is this location? You can able to find out the other properties. Okay, what is the moisture, what is the dry bulb temperature, what is the wet bulb temperature in that particular space. If you know that particular temperature, then you can able to treat the air, right? Say for example, if I want to treat the air, okay, I should know what is the present condition. Okay, then only I can able to treat the air. Clear, right? So that is the purpose. We are going to use the all other values, such as like a dry bulb temperature, wet bulb temperature. If you measure dry bulb temperature and wet bulb temperature, you can able to calculate all other values. So you will understand that what is the existing properties of the air. Then you can able to treat the required properties of the air, right?
Yep.
Okay, then if I go down further, so this is the basics of air conditioning again. There is outside air mixing that we can talk about in fresh air calculation. Okay, so the bypass factor, this is the air conditioning coil. Okay, so when it passes through the coil, there is some of the amount will be escaped. All right, so that will be the bypass factor. Say for example, 100% of the air will not touch the coil. Okay, it will not flush with the coil. There will be some of the air will be escaped through between the coil. So that is called bypass factor. What is the percentage? Sometimes 5%, sometimes 10% will be escaped. Okay, so that is the value also required to calculate your condition that we will see in coming classes, right? Okay, this is about air conditioning. And if you go to basics of air conditioning again, okay, there is estimating cooling loads. So this is what we are going to calculate basically. Okay, so what is the estimation? We are going to have consider external load, internal load, and other loads. Okay, so what is the external load? You can able to calculate here external load, heat gain by conduction through the walls, roofs, windows, and through internal partitions, ceilings, and floors. So whatever is coming from external side, okay, from outside to inside, so that is the external. So the external air, it can come through the walls, through the roofs, through the window, through the internal partition, or through the ceilings, right, or through the floors. So this is the external load. Okay, and when you talk about internal load, it is like, say for example, people, and then you have a lighting, then you have appliances and equipments. Okay, so whatever is in internal, so that is the internal loads. Okay, and other load is nothing but, say for example, you have a motor load. Okay, then you have a duct leakage and heat gain. So this is also considered other heat. Okay, so that also we will see in detail. Okay, you can see the picture, but we will have a clear picture in the coming slide. Okay, then the basics of air conditioning again. The next one, this is the ducting portion. Okay, when you estimate the heat load, then you can able to understand what is the capacity required for the machine, right? And also you have to calculate the static pressure. Okay, So you have a different air outlet, right? This is a distribution part. Okay, we have a separate class for the duct static pressure calculation based on Ashray method. So there we can see in detail, okay, like how to calculate the static pressure, ESP calculation, and different type of duct accessories, different type of air outlet, then different type of dampers. We can see in that particular section. Okay, then different type of fans. Okay, this is a duct design. So we calculate by using different methods. Okay, like you have a equal friction method, velocity reduction method, static regen method. Okay, and the most efficient method will be equal friction method. So the other two method will not be used in anywhere. Okay, so normally whenever all the design consultant will be using for the equal friction method, because the fan performance will be better compared to other methods.
So this equal friction, these methodologies are applicable for all types
All,
of buildings. Let's say
yeah, all type of
shopping
buildings,
malls,
everything.
residential, everything.
Yes, yes. If you go to any of the
Uh,
consultant, they design based on equal friction method.
Ducting.
But will be. Sorry,
Yeah.
you continue.
Yeah, you just finish.
No, just to so we'll be going deep in the equal friction method. Yeah.
Yeah, equal
Plus.
friction method. Yes, yes. There is a
So this
separate.
will be including the duct sizing and the,
everything.
Okay.
Pranit, this friction method is
Yeah.
applicable for air conditioning, mechanical ventilation, right?
Everything.
Everything. Okay.
Whenever you do the calculation for the ducting, you will use that method. Okay.
Fine.
Okay. So when you talk about the just for concluding part, we have talked about human comfort. Okay. Basically, what is the comfort level required? Okay. Basically 24 to 26 degrees Celsius and 40 to 60% RH. That will be the human comfort, right? And the properties of the air, understanding psychometrics. Okay. So this is the just for conclusion part they have given. So this also I have shared to everyone. You can go through to understand the basics. Okay. Whenever, don't read all in one day. Okay. Just try to read small topics. Even I'm also sharing some of the videos, some of the slides. Okay, just read that one. So slowly you can able to upgrade your skills. That's it. You cannot able to learn everything in one day, but just slowly you can upgrade your skills. Clear, right?
Okay.
Okay.